All right, so here we go. We've got to make a correction to this. So I told you that 1 mile had 1.609 kilometers, and I mixed it up on my previous example, so I will redo it. Kilometers go down here, and the 1 mile goes up here, so kilometers will cancel out. I know that 1 mile has 5,280 feet. Cancel, cancel. So I had to redo everything because I started wrong, okay? So here it's 3.5 divided by, right? I do this first and then I multiply it by 5,280. Is that what we got? Yeah, okay. Did some of you probably went to an online calculator and checked for yourselves, right? Like, did I do it right or did Mr. Dirksen? Okay, so 11,485.39. Oh, and make sure the rounding early doesn't affect you, right? So if you want to do this in steps, you got to use all decimals that you got here for the second step. Okay. All right. Next, E, yards to centimeters. So you start with that, and what I will use is I will use the fact that you could go meters, right? I'm going to go to meters. So 1 meter, no, it's 1 yard is that what I gave you? 3048, right? 1 yard has, you don't have to erase just yet. No. You might be right. What did I give you? 0.9114. Yes, sorry. This is 1 foot. Yes, thank you. 91114? 144. Okay. There you go. So now I'm in meters. I will just do a little, you can add it here if you want. That 1 meter has 100 centimeters, or you can just shift the decimal, right? But this cancels here, cancels there. So this is just multiplying the numerators basically, okay? 34,280 times 0.9144 times 100, and that is 3,134,563.2 centimeters. Don't do commas, okay? Just leave it, right? Especially the French students, commas and decimals, right? I'm not gonna dock marks. I know that some of you is just ingrained. If you go comma instead of decimal, it's fine, but there we go. Okay, so let's try. Let's continue here. I'm gonna call that converting rates. Okay. Follow same steps as before, but now we have 2 units to start with. Make sure you show how units cancel. Right, so A, let's say a pump is able to pump 42 gallons per minute. and you would like to convert that to liters per hour. So start, when you see something like this, it's essentially saying 42 gallons, right, in 1 minute. So you can actually write down 1 minute if you'd like, or just minute like that. And I would start with 1, like usually I start with the top. We need to go gallons to liters. Did I give you that conversion? If not, here it is. 1 gallon has 3.79 liters, right? That's probably one that you need to have on your study sheet. So I'm going to say that 1 gallon down here because I want gallons to cancel out. And at the top, I'm going to have 3.79 liters. Okay. Use a red here. So just showing that gallons cancel out with gallons there. And so I took care of the gallons and I get it to liters. It could be that there's another step required, like if it's, for example, milliliters, but it's just liters, so we're good. So just add another multiplication. We're going to use another rate. So minutes, I need that to go to hours, right? So I'll just make a note here. I know you know that. I'm just making sure that these are the rates that I'm using. And so 1 hour, which I want in the denominator, see here, will have 60 minutes. So this is a true rate, right? So the minutes, I'm going to use maybe blue. I'm going to just cancel the minutes with the minutes there. So now you're left with liters in the numerator and hours in the denominator. Okay, so maybe what I will do is, in this case, it's just this times that, right? There's nothing other than 1 in the denominator. So I'm just going to go ahead and multiply that all. I think 955.08. Is that correct? I'm going to double check that. 9,550, right? That's what did I do wrong here? Oh, it's 42. I think I was just, yeah. That's what it is there. Yeah. Can somebody, oh, that's the door. Yes. Oh, come on in. Come on in. I will, I'm in the middle of correcting my mistake here. There. Okay. Okay, so we have 65 miles in 1 hour. So we can tackle the miles and try to get that to meters first. So we have that 1 mile has 1.609 kilometers, right? I gave you that. Pay attention. Miles and miles are gone there. I know that 1 kilometer has 1,000 meters. I can cancel kilometers and kilometers, so now we're to meters. We're good there, correct? Okay, right? Okay, so then I'm gonna try to take care of the hours. So you can do this in 2 ways. You just know that 1 hour has 3,600 seconds. If you just remember that, right? Because it's 60 times 60, right? So we have that 1 hour. I'm going to put this on top because I want to cancel it with hour in the denominator, and that's 3,600 seconds. Instead of doing 1 hour has 60 minutes and then 1 minute has 60 seconds, right? We just do it in one shot. But it's not wrong to have those two. It's just a bit more work, maybe. So I will cancel the hours with the hours here. Okay. So this is quite a bit of work, correct? But you just need to make sure do one first, right? The top, I converted the miles to meters, and then I take care of the denominator, which is in hours, and I try to get that to seconds. So you have meters and seconds. What I'm going to do here is, as I'm going to do this in steps. So 65 times 1.609 times 1,000. Sorry, you can't see that, right? I'm just going to multiply the, is that 100 or 1,000? Hold on. 1,000, sorry. So you get that in the numerators. I'm going to go 104,585, and that is now in meters. And I still have the 3,600 seconds here. Okay. I'm now going to divide like that. And that is the equivalent of 29.05 meters per second. Can you add this now? Because we're going to talk about that. This should be considered a rate. And this is what we call a unit rate. What's the difference, you may ask? Instead of saying the distance over 3,600 seconds, we actually figure out what it is for 1 second, right? A unit. So this is a unit rate, and this is just a rate. If it's over 1, we call that a unit rate. And I will add to that. I will give you some notes on that. I just thought I would do this conversion right away. And I could go from meters per second to miles per hour, or I could go yards per second to miles per hour. This could go any way. So just try to focus on the skill of canceling out. Have you done this in science, this kind of stuff? A lot of you will have. So maybe there's a little variation with how that teacher taught it, but the principle remains the same. Okay? We're good? Okay, next page. So a rate right? A comparison between two amounts. Measured in different units. Example, right, 240 or 204 words per minute, 20 kilometers per hour, etc. Unit rate. Can we do 20 kilometers in 3 hours or something like that, so that it's and the 204 words per minute, I'd rather have it as 5 minutes or something like that. I just don't want the denominators to be out of 1 because now I'm going to define unit rate. Sorry about that. Don't want to mess up your notes. Okay. Unit rate, a rate in which the denominator is 1. Okay. Oh yeah, sure. Is that better? Okay. I'll write a little bigger as well. Okay. This can be done by dividing the top and bottom by the denominator. Example, if you have 240 words in 8 minutes, let's say, and this would be a rate. If you were to divide both of them by 8, so you take the denominator and divide both of them by 8, that's when you get 30 words. And obviously the denominator will just be 1, right? We tend to write, instead of writing it like this, we tend to write it like that. This is a unit rate. Either one is fine. I'm not going to mark it wrong if you write it like this or like that. I just need you to know. Yeah. 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 Even miles per hour is usually mph. So yeah, those little things will come up. Yeah. All right. Let's keep going. Comparing rates or right, just a subheading. So either comparing rates or determining the best buy. Units need to be the same. Convert as needed. Find the unit rate. State the better rate and by how much. A 12.8 kilogram turkey at Safeway for $42.89, or a turkey at Superstore $1.49 a pound. And I like to do them side by side. And you will see that there's more than one way of doing this. Okay, you can convert, what we do know is that, let's start off with this, right? 42.89, right, for 12.8 kilograms. And at Superstore, we have 149 for 1 pound. Okay. Now, I would say this, in general, for us, right? Okay, note here on the side, dollars, right? Always in the numerator. It'll just make it a lot easier, right? The dollar, we'll keep the dollars, like some students will flip it, they'll put 12.8 kilograms and how much they paid. It's not wrong, but it's easier if we're all on the same page and we always have the price, because most of the stores will have the price per amount, right? Like that's just how it is. And so let's stick with that. So you have a choice. You obviously dollars is, we're good here, but we notice that our weight is different, right? So you need to either convert this to pounds or you convert this to kilograms. You have to have the same units, right? And I make a note that this is already a unit rate. So I am thinking it's already a unit rate, leave it alone. Let's work with the other side, right? So I'm going to convert it. So we know that 1 kilogram has 2.2 pounds. And I'm going to run into trouble here. I'm going to have to be careful with my room. But I can cancel the kilograms. I'll be left with dollars in the numerator, and I'll be left with pounds in the denominator. Great, right? So this is 42.89 over 12.8 times 2.2. I'll quickly run this through here. That's 28.16 pounds. We have the same units, right? But this is just a rate. We want the unit rate. So let me just bring this over here again. And I'm just going to go ahead and divide both by 28.16. So I get 1.52, and this is obviously just 1 pound. Unit rate. Check, right? So you got it. Can I just warn you one thing? Some of you are going to want to convert this to a unit rate right away and then convert. You just have to be careful not to round too soon, okay? It's okay to do that, but I would say convert to the unit you want and then convert it to a unit rate. Do that at the end, okay? Okay, so obviously, in this case, which one is better? Superstore or Safeway? Superstore, yeah, exactly, because Superstore has, it's less per pound, right? So sometimes I think it's just a given, but some students are like, no, the bigger number is better, right? It's like, no, you're buying, so for you, this is the better buy. Better buy, sorry, by how much, right? So we'll just do the math here on the side, right? 1.52 minus 1.49 and it's 3 cents, right? Not a whole lot. But it's not just 3 cents, folks. It's 3 cents per pound. Okay, don't forget that. So buy, I know it's not a whole lot. That's not the point right now. It's just making sure you understand that it's 3 cents per pound that you'll be saving at Superstore. Is it worth driving over if you're already at Safeway? Probably not, right? Like, it's not worth it. But it's just a point of calculating and figuring that out. Okay, let's see here. I want to do a fuel economy question, but not just yet. I'm just going to skip that for now. So let's add here, which is faster? And by how much? Okay, so first I'm going to give you, let's just start with 1 here. We have 14.2 meters per second, or 50 kilometers per hour. Okay. So obviously they're both as a unit rate, so it really doesn't matter which one you pick. Which one do you want to convert? That's up to you. I'm going to convert this one to kilometers per hour. Okay, so I'm going to do a 14.2 meters. I'm going to put the 1 second here. And I know that 1 kilometer has 1,000 meters. And that cancels out the meters here. I have what I want, which is kilometers. And I know that 1 hour has 3,600 seconds. And so that allows me to cancel out the seconds here. Okay. So this is what your setup should look like. So then we go and grab our calculators and we go 14.2 times 3,600. So I get that in my so you have kilometers up top and you have hours in the numerator. So I'm going to divide both of them by 1,000, or just divide it by 1,000. That's okay. That's 51.12 kilometers per hour. Okay. So I would like you to make a statement here, and this is easy to figure out by how much, right? So you tell me that 14 meters per second is faster, comma, by 1.12 kilometers per hour, right? That way you're telling me out of these two, you did some calculations to get it to kilometers per hour, but you're really saying that this one is faster, and you're telling me by how much. If you had converted the kilometers to meters, right, that's okay. You still would have arrived to the same conclusion, and you still tell me, give me a concluding sentence, right, to tell me which one is better. All right, let's try another one. How are we doing? You're not falling asleep, are you? Okay. I'm taking it easy for a little bit, right? And I will get a little faster, so don't get too comfortable, okay? B. I'm not scaring you. I'm just be on your toes, right? Sports, toes, right? Like you're always ready to go. Let's see here. I have 20 meters per second or 30 miles per hour. I would like you to try this on your own right now. I'm going to pause my recording. Let's give this a try. I think I'm going to give this a try both ways, right? So I'm going to convert one and the other. So whichever way you chose to go will be marked correctly. Okay, so 20 meters per second, right? We have that. I'm going to convert that first. I want that to miles, right? So I'm thinking a little bit. I know that I can go from meters to kilometers, right? So I'll try that. 1 kilometer has 1,000 meters. That allows me to get rid of the meters here. And then I know I gotta get this right. Hold on. 1 mile, because that's where I messed up right earlier, has this many kilometers. So kilometers cancel out. So now if I did this, I would have miles per second, right? As it stands. So I need to get rid of the seconds. So I know that 1 hour has 3,600 seconds. So the seconds here go with the seconds there. And now I look, it's miles and I have hours, okay? So I'm going to do this like that. And I'm going to get the 72,000. This is just to make sure you don't make a mistake in dividing or multiplying, right? So this is really just this ends up being 44.75 if you round to 2 decimals, right? Miles per hour. Is that good? Yeah. So you could conclude if you went this route, right? You could say 20 meters per second is faster by, and you can just do the mental math here, right? 14.75 miles per hour. And that would be it. Okay. Let's convert the 30 miles per hour to meters per second. Oops. So you have that 1 mile has 1.609 kilometers. Miles go here. I know that 1 kilometer has 1,000 meters. Cancel that out. I know that 1 hour has 3,600 seconds. Hours cancel out. And let's see what we get here. You have 48,270, and that is in meters, over 3,600 seconds. And I'm just going to do one more calculation. 13.41. Sorry guys, I'm running out of runway here. Meters per second. So you could still conclude that 20 meters per second is faster by, here I got to do a little bit of math because I'm off today, 6.59 meters per second. So regardless of how you convert, you can still say that this is the faster speed, and then you just tell me the difference, right? Does that make sense? I think you can wrap your head around it. I think you've seen this enough. This might be a little bit more complicated maybe, but it can be done, okay? So I did both ways. I won't always do that, but when I make my key for the test, I do have both, okay? All right, moving on. Fuel economy. I will give you a formula for that. Liters over kilometers driven times 100. And you state as liters per 100 kilometers. That's how you state your final answer. I would have that formula on my, it's boxed in, right? Don't use up too much space though. Make it nice and small, right? Like it's not going to be like you're going to be bombarded with fuel economy questions, but if you do, then it's there, okay? All right. So let's do a word problem here. You start a trip with the odometer reading of, I'm talking as I'm writing because I've had students tell me that it helps them. Then they don't need to look up all the time. So I'm not crazy, okay? Trip with the odometer reading of 0 kilometers, okay, with a full tank. Okay. On the first leg of the trip, you drive 645 kilometers. This could be in miles, this could be in anything. I'm just choosing to go kilometers. Then add it where am I here? 48 liters to fill up. How's the writing? Can you read it clearly? Yeah? It's not the best, I know that, but I tried. In South America, we always had to do cursive everything. So when I moved, I had to so I'm mixing it up sometimes, okay? Like here, you can tell, right? Some remnants of the, anyways, fill up. On the second leg, you add 32 liters to fill with an odometer reading of, 1,031 kilometers. Determine the fuel economy of each leg. B, which leg had the better fuel economy. I'm trying to save you. That's why sometimes when I write out my word problem, it's kind of cut up in a weird way. It's because I'm trying to make it shorter so you don't have to copy the whole thing. Okay. .47 is my time, so I got to watch that. Okay, so we need to determine the fuel economy for each leg, right? So for A, first leg, it's going to do fuel economy is liters per distance, right? Distance times 100. So I used, for the first leg, right, you start your odometer at 0, you drive 645 kilometers, sorry, you can't see that, right? 645 kilometers, and you fill up 48 liters. So the 48 liters will go up top, the 645 kilometers goes at the bottom, and then you go times 100. Fuel economy 1, right? Sub 1. 48 divided by 645. Here it is, right? Times 100. That's 7.44 liters per 100 kilometers you drive. That's what you just calculated. Okay? 7.44 liters per 100 kilometers. You have to state it like that. Second leg, the fuel economy. I won't write down the formula again, but I do know that I drove, or that I used 32 liters for that stretch. And here's the tricky part, right? Like what's the distance you drove? Your odometer shows 1031, but you technically, when you fuel up, right, the reading you took at that point is the 645, right? So you need to subtract the 645 from your odometer reading to actually see the distance you drove since you last fueled up. Okay, I think that makes sense, right? You got to find that distance. So watch out for that, times 100. Fuel economy is 32 over, that's 386 when you subtract that. Times 100, sorry, that's liters and that's kilometers. Watch for units. This could have been one could have been in miles and one could have been in kilometers, right? So always make sure you have the same units. In Canada, we tend to give everything in liters per 100 kilometers. So when you divide this and you multiply it by 100, you get 8.29 liters per 100 kilometers. So let me ask you, which one is the best fuel economy out of the two? Leg one? Yeah. And it is because you're using less fuel to drive the same distance, right? So you're like, Mr. Davidson, what about the unit rate? You told us to do the unit rate, like liters per 1 kilometer. You could do that, but it would be a very small number. And this is the standard in Canada that we use, okay? That's why I prefer it this way. So this one is the best, right? Better. First leg, right? I'm okay with you doing something like that. Just indicate clearly which one is the better one. And then by how much? Let's do the math on the side here. Right? So that's 8. So 85.85 liters, right? By 0.85 liters per 100 kilometers. So almost a liter less per 100 kilometers. I would always show work on the side just in case you make a mistake. I can still see, oh, okay, you just didn't subtract correctly, but you know what you're doing, right? All right. Okay. I think I'm gonna let this be it for in terms of newer stuff. So just write down homework. page 1 in the booklet, right? So booklet, page 1 in the booklet, and just do questions like the first half, because there's there is 1 and 2, and then there's 1, 2, 3. First half only. Sorry, I'm running out of room here. So I will show you. If you look on your screen, it's this one here. Okay. So I just want you to do half of it, like just this part here, 1 and 2. You can actually write it on here, right? For Monday, do first half, and then the second half you can give it a try, but I will give you some examples on Monday on how to do those. Okay.